All right, we're there. We're climbing the mountain. Yo-dee-doo-doo-doo-doo-doo-doo-doo. As this guy's going up and up our mountain here. Here he goes up the mountain. This is you guys climbing the fraction hill. Fraction hill, that's what you guys are on right now. This is almost the end of all of fractions. I had a choice here. I could have used this guy. I thought this guy was pretty good. To the top and to the tippy top. You see the difference between the top and the tippy top? Not much, eh? Here we are. This is the last thing you're going to do, some of you in your whole life, about fractions. This is about as much as fractions go. And if you remember back to like 3rd grade, how much you disliked fractions, you've probably disliked them the whole way. So if you liked them back then, maybe you've been fond of them the whole way. But I know somewhere around 6th or 7th grade, we learned something about cross multiplying. Cross multiplying was that thing where you'd have like 1/2 equals 3/6, and you could cross multiply and get 6 times 1 equals 2 times 3, and that's true, and that's great. Cross multiplying also lends us to a lot of things. One of them is that I could swap this 3 and this 2, and I could say 1 over 3 equals 2 over 6. And it's kind of the same concept as cross multiplying, and it ends up being a true statement. And that comes in handy when I'm doing a lot of this math work. So let's take a look at example 1 here and see what we got going on here. If I cross multiply this thing, it's simply 20 times x minus 2 and 5 times 3x minus 5, and then I just solve that. So I get 20x minus 40, and I get 15x minus 25, minus 15x from both sides, I get 5x, plus 40, because it's a minus 40, plus 40, so I get 15, divide by 5, x equals 3. And then I should always check my work on all these types of problems. So if I put a 3 in there, I get 20 over 4. 20 over 3 times 3 is 9, minus 5 is 4. 20 over 4 is 5. And if I put a 3 into here, I get 5 over 3 minus 2. 3 minus 2 is 1, and that's 5. And check, it worked. Excellent. You guys go ahead and cross multiply checkpoint number 1. Let's see how you do with that. Pause it, take a moment. All right. So hopefully you ended up with, when you cross multiplied this, 9x plus 24, and when you cross multiplied this, 6x plus 12, minus 6x got you 3x, minus 28 got you negative, 3 times 8 is 24, Mr. Emeott, 24. So when I minus that, I got negative 12, and when I divided by 3, I got x equals negative 4. Wow. Wow. Well, I'm going to leave it in there. I'm not even going to edit it out because I want to show you that I can make mistakes too, I guess. On this next one, when you cross multiplied it, you got negative 6x plus 6. I hope some of you guys caught that mistake because you had paused it and knew that that mistake was there. That would be great. Maybe if a good teacher would probably say he did that on purpose, but not me. So we had negative 6x plus 6, because a negative times a negative made a positive, and then negative 12x minus 24. And so I would add 12x and get 6x, minus 6 and get negative 30, and divide by 6, and x equals negative 5. Hopefully you got those answers. Let's take a look at this page here. Now on this one, when we're looking at example 2 here, if you'll notice, you got this one, 8 over x plus 11 over 3 equals negative 14 over x. Now, what we're trying to do is solve this equation. We need to figure out, first of all, how to combine these things would be a great deal of help so that I could put them together. The textbook is doing something a little different on this one. What the textbook is doing is saying if you multiply both sides by 3x, you'll clear out those fractions. So let's let's go their route. They chose 3x because 3 times x was the common denominator. So if I multiply everything by 3x, let's see what it says here. If I multiply it here, that x's eliminate, so I get 24 plus. If I multiply it here, the 3's eliminate, so I get 11x. 24 plus 11x equals, on the other side, the x's eliminate each other, so I end up with negative 42. Not too bad. And I get 11x equals negative 66 after I subtract 24 on both sides, and I divide by 11, and I get negative 6 as a solution. Yeah, that's not bad. I don't mind that at all. Probably a little bit easier to do than I was going to go and try to find a common denominator and cross multiply. Probably still would have worked out. My method, I probably would have called that 24 over 3x, because I had to multiply the top and the bottom by 3, plus 11x over 3x, because I had to multiply the top and bottom by x, and I'd have had 24 plus 11x over 3x, and the other side would have been negative 42 over 3x. Looks pretty similar to what we had there. So pretty good stuff. Example 3 here, you got a checkpoint coming up that you're going to have to do. On this one, boy, big gnarly mess here. We got a lot of stuff going on. You want to be very careful when you're solving this one. If I have to find a common denominator for this to combine them, that's probably where I'll focus first. So what I would do is I would take that thing and I would multiply it by 2, and then x plus 3, x minus 4 on the top, and x plus 3 and x minus 4 on the bottom, because it was 2 over 1 to start. And what that would do for me is it would give me a common denominator on the one side. And because my handwriting is going to be, I want to be able to write a little smaller here. I'm going to resize this. And so what I would have on that right side might help me a little bit. Now, it looks like I'm probably doing a little bit different than them. So if you could do this maybe in your column, maybe in the side margin or something. I'm going to keep it so I can see the problem, and then I'm going to work over here a little bit. So what I would have on the right side right away is 2 times x plus 3, x plus 4, x minus 4, plus 8 over that thing, that same thing, and now I have a common denominator, and I can add. And then when I add them up, I get 2 times x plus 3, x minus 4, plus 8, all over that common denominator that I had. If I want to, work that whole thing out, there's a lot of stuff that'll happen here, but first and foremost, let's do 2 times x and 2 times 3, and I get 2x plus 6 times x minus 4, and then I FOIL that. 2x times x and 2x minus 4, and I get 2x squared minus 8x. That's the first and the outsides. The insides would give me plus 6x, and the last would give me minus 24. Don't forget, I still have a plus 8 on the top of that. So let's move it up here a little bit. Plus 8. Okay. Now, and that's still over x plus 3x minus 4. Don't forget about that. Now I have 2x squared minus 2x, and then it looks like I'm going to have a minus 16 there, over x plus 3, or x plus 3, and x minus 4. And that's going to equal that other side, which was 3x plus 5 over x plus 3. 3x plus 5 over x plus 3. A lot of work here. You have to be careful when you're doing this much work, but if you're just step by step and you do things the right way, you'll be fine. What I see is an x plus 3 and an x plus 3, and those things are going to eventually knock each other out because they're both on the bottom. So if I just take this and I'm going to multiply it to this side over here, I end up with x plus 3 times 2x squared minus 2x minus 16 over x plus 3, x minus 4, and those x plus 3's eliminate each other, equals 3x plus 5. Now I take this, multiply it here, and I get 2x squared minus 2x minus 16 equals x minus 4 times 3x plus 5. Whew! This is a lot of work, this problem, isn't it? Better Mr. Emeott than you, I guess, eh? So x here and x here, I wonder if your checkpoints will be this hard. 3x squared plus 5x minus 12x minus 20. Okay? Still equals this here. 2x squared minus 2x minus 16. Now, I'm thinking right now I'm going to have to start using the Pythagorean theorem. So what I'm going to do is I'm going to get 0 on one side of this equation. So I'm going to minus 2x squared minus 2x squared and add 2x. Oh, this is going to be a negative 7x right here. I'm going to add 2x to it. And I'm going to add 16. So I'm going to get 0 equals x squared and minus 5x minus 4. All right. Now, can I factor that thing? Is there any numbers that multiply to be 4 that add to be 5? I don't think so. And so it ends up having some different kinds of answers in it, that's for sure. If I put it into the quadratic formula, A equals 1 and B equals negative 5 and C equals negative 4, that would lead me to an answer. Okay? And so I'm going to do, ready to sing, everybody? X equals the opposite of B plus or minus the square root of B squared minus 4A. 4A is 1. C is negative 4. All over 2 times A. And that gives me 25 plus 16 in the discriminant. And so I have the square root of 41. 5 plus or minus the square root of 41 all over 2. Wow. Tough problem there. And you guys, I hope, are not going to have to do one as hard as me. Take a minute and try to solve those ones there. All right, welcome back. I hope you were able to tackle this at least a little bit. Maybe on this first one, what you did is you multiplied the top and bottom by x, and the second one top and bottom by 4, and so you got 11x over 4x minus 12 over 4x equals 5 over 2x. And then so you had 11x minus 12 over 4x equaled 5 over 2x. If I just straight up cross multiplied this, I would lead me eventually to a right answer. I would end up with 22x squared minus 24x all over, equals 20x. All right, if I multiply the other side, right? Equals 20x. And then if I were to subtract 20x, I'd get 22x squared minus 44x equals 0. From here, if I factor this thing out, it would lead me to the solution. And so let me show you how to do that. 22 goes into both of these things. If I divide everything by 22, including the 0, I'd get x squared minus 2x equals 0. If I were to divide everything by x, including the 0, I'd get x minus 2 equals 0. Therefore, my answer would be 2. And maybe you found another way to come up with 2 that was quicker than mine, but that was the method that I would have used. Now, number 4, maybe it was a little bit easier. Call that x plus 2 over x plus 2 times 1, which is just that, plus 4 over x plus 2 equals 9 over x. 4 plus x plus 2 is x plus 6 over x plus 2 equals 9 over x. And then if I cross-multiplied that thing, right there, I would end up with, can I do something here real quick? Alright, that's not going to work. So if I cross-multiply that to there and that to there, I end up with, yeah, I know what I can do. I can just make myself some more scrap paper over here. I end up with, let me try to, for those of you who are listening, this probably isn't hard. For those of you who aren't listening right now are thinking, what is going on? X times x plus 6, if I cross-multiplied there, and 9 times x plus 2 over here, and I get x squared plus 6x equals 9x plus 18. And if I subtract the 9x, I get x squared minus 3x minus 18 equals 0. And numbers that I multiply together to get 18 and add together to get 3 would be 3 and 6. So I would have x minus 6, if I factor that, x minus 6 and x plus 3 equals 0. Holy, I apologize for all this. And therefore my answers would be 6 and negative 3. Whew, that was a tough one. All right, on to our last page of notes. So here we are, example 4. A nasty, nasty beast of a problem. It's got everything that you could imagine. The only good thing that this problem has is a least common denominator of x squared minus 16. I hope everybody sees that x plus 4 times x minus 4 is x squared minus 16. That's the difference of squares we learned in Algebra 2A. So if I turn that into x plus 4 and x minus 4, that x squared minus 16, all right, and I said, you know what I'm going to do? I'm going to multiply both sides, the whole side, by x plus 4 and x minus 4. What I would find is that the x squared minus 16 down here, when I multiplied it times this would eliminate. And then when I multiplied times this, the x plus 4 would eliminate. So I'd end up with, on the left side, on the top, 6x squared would still be there. But then the bottoms would be gone, and I would minus 3x times x minus 4. 3x times x minus 4. That's what the left side would look like. On the right side, if I multiplied by that whole thing, because if you multiply the left side by something, you got to multiply the right side by something, the x plus 4 would still be there, but the x minus 4 would eliminate the bottom, and I'd end up with 4x plus 16, because I multiplied the 4 times the x and the 4. All right, so if I go through and I do all the work, and they certainly, on this one, I don't think I'm at fault here, they didn't give me much space to do work. I'd have 6x squared, and it was a minus 3x. A negative 3x times x is negative 3x squared. And I also have a negative 3x times a negative 4, which is a plus 12x. That's what I ended up with on the left side. If I subtract this 4x right here, this 4x right here, if I subtract it from this 12x right here, I end up with 8x. If I combine these two, I end up with 3x squared. And if I subtract 16 from both sides, that's just a negative 16. So I end up with 3x squared plus 8x minus 16. Whew. And what your book would have you do at this point is to factor that. Now, I don't know if you could factor it or not. Either you're putting it in the quadratic formula or you're factoring it. I would guess most people would put in the quadratic formula. But if you're going to do that, you could do that on your own. So if we're going to factor it, we would say 3x on one side and x on the other side. Certainly 3x times x. And then numbers that multiply to be 16, 4, and 4. But see, the 3 gets multiplied by a 4 over here to give me 12, and you subtract 8 to get the 8. That's pretty tough. If you did the quadratic formula right there, you'd come up with this same answer. And the answer ends up being 4/3 and negative 4. The only problem that there is with these two answers that you have, one of them is called an extraneous answer. The solution 4/3 is beautiful, that works. But the apparent solution negative 4, if I look up in my original problem right here, that x plus 4, if I do negative 4 plus 4, I get a 0 on the bottom. I cannot divide by 0. So that's bad news. And so we call that undefined or extraneous. So what I undefined, let's try to see if Mr. Emeott can spell. Undefined. So then I take this and I X it. I X out that answer. I double circle the 4/3 and I say that is the right answer. Okay. You guys are going to try this problem. Good luck. I'm going to give you the answer to this problem. And we can discuss this in class. The answer is 1/2. I don't know how many extraneous solutions are there, but check that out. Do your best, and we'll talk about it tomorrow. Thank you. Good luck climbing the mountain. We're almost at the peak.